Hello everyone, it's my great honor to present our paper named Learned Image Compression with Wavelet Domain Convolution and the Entropy Model. My name is Haisheng Fu, a postdoctoral research in Stimmen-Free Universities, and I first would like to thank all of our co-authors. As we know, learned image compression also include nonlinear transform quantization and entropy model, and our goal is to achieve a better trade-off between coding performance and complexity. In this paper, we want to combine the traditional frequency domain techniques to convolution neural networks, and we also want to balance performance and complexities. We can conclude our contributions. The first contribution, we propose the WeCom layer and the WeCharm layer. The second part, we improve the performance and reduce the complexity. In this part, we will introduce the proposed framework. Our framework is very similar with the recently method. It includes an autoencoder. It can be extract the latent representations, and a hyperparameter network is encode set information for better entropy coding. The input image is processed through the encoder with the user rest group model and our WeCom layer for efficient downsampling. At the end of the encoder, described wavelet transform DWT is used to convert the latent representation into wavelet domain. To improve the sparsity and subsequent quantization, the wavelet coefficients and the quantized under entropy code by using WeCharm parts for both the low frequency and high frequency subbands. Hyperparameter network further enhanced the entropy coding parts. The figure below is the detailed structure of our proposed wavelet domain convolution models. We first use the convolution for upsampling and downsampling, and then we will use DWT to convert the tensor to frequency domain. It can be include low frequency parts and high frequency parts, and we will use convolution to process this low frequency parts and high frequency parts. After that, we will use the inverse DWT to convert this tensor back to RGB domain. The second part is the proposed WeCharm model. We first use the DWT to convert the latent representation from RGB domain to frequency domain, and we will use the separate channel-wise auto-regressive entropy model to encode and decode these two parts. But we first encode and decode low frequency parts. This can be considered as prior information to provide for encoding and decoding high frequency parts. There will be reduced a lot of redundancy in high frequency parts and will be improved the performance. This is our loss of function. It includes two parts. The first part is distortion. The second part is entropy part. We will use the lambda to adjust the width of the distortion part and the entropy parts. We test our method with some recently method and traditional image codices, including VVC444 in Kodak dataset. It can show our method achieve the best performance. To test our method robustness, we also test our method on technical dataset and click datasets. The results show our method achieves the better results than compared method. We also test our method in GPU. We can see our method can achieve the better performance and between the decoding time and the parameters. This show can directly show that our method can achieve the better performance between coding performance and decoding time. Thanks, you are listening.